Hello all and welcome back. So in this video, let us continue our discussion on linked list and now let's try to implement our own linked list as well. So let's get started. Now, if you remember in the last class, we saw that how each element of my linked list will be having two things. The first one was the data. What exactly is the data of that particular element? And the second one was the address of next element in line, right? Now, this particular structure, right? This structure where we say that it is having a data and the address, it is known by a name called node. So what I effectively say is that my linked list, it's a collection of nodes where each node, each and every node is having some data and address of the next element or next node in that particular structure. Now, if you actually remember, we have not studied any data type where we have a structure like this, right? So where we can say that, okay, hey, one data is there and an address is there. So no data types as such we have studied, which is inbuilt in Python or throughout the course as of now, we have not done that, right? But we have learned about OOPs or classes. And one very common name of classes used to be user defined data type. User defined data type. Now, if you're not remembering what exactly classes were or concept of OOPs were, will highly suggest to see the class after this video once to revise the same because we are going to use that a lot going forward. Okay, cool. Now, what I can do now is using this knowledge, equipped with this knowledge, I can create my own class, my own data type, which I can say that will be node. Okay, and like this will be the most fundamental unit of my linked list. In this node, I can say that hey, you are going to have one data, and of course, constructor will be there. So we can say that init. Okay, and you are going to have a next. So I'm saying the address as next. Now, initially, we can of course ask that, hey, what value you want to use. So maybe we can have some value through which we want to save. So value. For the next, I can say that initially my next is none. Now, why exactly is this none? Let us understand. See, so this is my node, right? This is one node which will be creating. Whatever value I pass, you're going to say that your value is going to get stored here. Okay. Let's say I pass one. Now, as of now, this node is not pointing to any other node, right? We will have to still make that connection. First, your node will get created somewhere in the memory. Okay, it will be having some address. Let's say 0x10 is the address. Okay, so now what I will be doing is I have to still connect it. But as of now, there is nothing. There is nothing this node is remembering as the address of next node. So that's why I say that this is none. Okay, so that's the most basic structure because of which through which we can create a node. Now let's move and actually implement the same in our code as well. But just one more thing before we move forward, I want to showcase you some examples through which you can better understand and always remember what linked lists are. The very first one is that of a playlist. So we all must have used YouTube playlist or Spotify, right? In that, we can actually create playlist. Now, if you understand, there used to be the next button in that. Now, what this next button signifies, it is taking you to the next song, right? So don't you think the structure is something like this only? Again, the note structure, where this is a structure, this is a song, and this is pointing to the next song. Now, there is no requirement that all the songs should be kept one after the another in a continuous place. For example, this Flowers song by Miley Cyrus, maybe it is kept somewhere else. And this Kill Bill song is maybe kept somewhere else in the memory. But again, using the same mindset of linked list, I can actually create this structure, right? Where you can ask or help your user to create a playlist. You just have to make sure that each and every song which gets added, you are maintaining your playlist structure. Great. Second, very relatable example is treasure hunt. So in treasure hunt, what we do is we start with some particular position and we just know the clue to the next position. And normally it is said that, hey, when you will go to the next position, the using your clue, there you will get where next you have to go, right? So this is exactly how your treasure hunt gets played, right? So you have the first index, first clue. It is having the information about next clue. Let me draw this only. So this is your first clue, let's say. This is having all the information about your next clue. So this is having the next clue information. Now your next clue can be, let's say, somewhere here. Okay. This will be joined in this way, right? Somewhere like this. This will be joined. And then keep on like using the same principle now. What you can do is you can reach out to the finish line or the last overall node in your treasure hunt, right? So that's another example. The last example is the browsing history. So in browsing history, if you see, we go forward and we can go backward. So using some special linked list, which we are going to cover later in this module, we can actually implement the browsing history feature as well, where we remember that, okay, what was the last page you visited and what is the forward page, let's say, you visited, which you have just came back. So again, this is all required so that you understand that, yes, it might seem a lot trivial initially, but they are used in a lots of places. So tomorrow, if you're making any particular, say, this treasure hunt game in your software or something, linked list is something which you can fall back to. Okay. Cool then everyone. I hope these intuitive examples are clear. So now let us go and code our own linked list. Okay, great. So the very first thing, we have to create a class. So let me just write create a node of LL. So we are going to create a class and I want to say that it is a node class, right? Now in this, I have to first create a constructor. The constructor has self and I'm saying that I will get a value. Now, if any one of you is having problem in remembering that this particular structure, please make sure that you see the oops class after this video, because we are going to use this a lot going forward. Now, here I have just created a node class. Okay, this is having a self. Okay, and in this constructor, it is having a value. Now, what I can say is in my data, please put the value and please make one next as well, which is none initially, right? So this is how we create a class. Now, when this class will be invoked, the data will be having the value which you provide and the next, okay, will be having none. So let me show you that as well. So let us create a first node. First is equals to node of 1, right? Now if I will run this, again, nothing is going to happen here, but what I can do what I can help you to do is visualize this particular thing. So pay attention. Yeah. See, when I create this node class, it gets created. So in the global frame, we have in this node class, it is having a constructor. When I call this first, what is going to happen is that this first will call this constructor, right? This constructor gets called. In the self.data, I am passing the value as 1. So it's going to use that value. And one node instance is going to get created. Again, this is all just basic classes stuff, but I want to make sure that you are able to understand very much properly on what exactly goes behind the scene in a linked list. So a node instance is going to get created with data is equals to 1. And because we are saying the next is going to be none, next is none here, right? So this exactly is your node now. First, data 1, next none. You can see that how it is very analogous to something which we were drawing, right? Great. Now moving forward, I can again create a second node and I can create a third node as well. Nice. So as of now, these nodes are not connected to each other. As of now, just the random allocation in the memory have been done, where each and every of these nodes, right? Each and every of these nodes, they are just created. Each and everyone is having some data and the next is exactly none. So something like this will be created in the memory. Now to connect them, what I can do is, if you remember, we used to have an ID function, right? So this ID function used to return us a unique identity of an object. Okay. So this is something actually which kind of we can use to say that, hey, can you please remember first, can you please remember the ID of second? Okay. So what we can do is pay attention. First, let me first show you the IDs. Print ID of first, ID of second, and ID of third, right? Let me run this particular thing and you will see that we are getting some IDs, right? Now what I have to do is, if I say that first dot next is equals to second. Okay, then this is something which I'm doing where I'm creating the linkage. So at this point, all I'm doing is I'm just saying that I have this first created in the memory, I have this first created in the memory, and I have this second as well in the memory, right? I have this second as well in the memory. All I have done here is just created this linkage. So I've asked my first that, hey, in your next, please keep second. How can we see that? Just let me print the first dot next. Okay, so let us run this. We are seeing this particular address, right? We are seeing this particular address. Maybe I can copy this. I can copy this and just remember, let me copy these as well, because in the next run, this is going to get changed. See, so these were the output I'm getting. Now this is the address, right? If I just try to print ID of this, we will see that, sorry, not ID, int. So this is the hexadecimal representation, and I will also be drawing the address like this 0x10, 0x20 to showcase. We can actually see that, okay, this will be equal to this particular address because we saw that how in first dot next we kept second, right? So I've just saved this because in the next run, they will again get randomly allocated. So let me just do one thing. Let me just, as of now, for the time being, just comment everything and not just show you, right? See, this is coming out to be 43739,344. See, 344. So what does that effectively means is that in my first dot next, I am storing the ID of my second. Okay, again, this is very important to understand as well, that how you are storing the ID. That is the unique identifier, right? Now let me uncomment everything. Now the problem is if I will run this again. So let me just remove this because these addresses are going to be changed, right? If I run this again, see, now there are some different addresses. But anyways, let me just remove this. I hope you understand this perfectly, everyone, that how what exactly is happening here. Now, in a similar manner, what I can do is I can say that, hey, second, can you just remember what third is? And now I can create my head and say that, okay, head is equals to first. Okay, this will actually have created a linked list in the backend. To understand and show you the same, let me just run this whole in Python tutor again. So pay attention, everyone. Now you will be able to understand exactly so how the things are happening. See, first we have created a node, class node. It's going to create a global, in the global frame, it's going to create a node class. Now moving forward, we are creating the first node. Okay, first node. It's going to have a value which is 1 and address the next which is none. So next is none, data 1. Let's go forward. Similarly, second and third can be created. So you will see the second and the third now getting created, right? See, first, second, and third. Now I'm just printing their IDs. Should be fine. We can see their IDs. Okay, they are little. They are of course different here. Okay, good. Now when I say first dot next is equal to second, you will see how this particular none will now point here. See, so this none, this is now pointing here. Similarly, when I say second dot next is equals to third, we will see how it is pointing here. And finally, I can create a head. Finally, I can create a head, right? So it's a little bit tangled as of now, but let me show you. The head is kind of pointing here. And from this, I can access my whole list. To make it a little bit more clear, let me just write one more line. That's going to make it all a lot more clear. So actually now we can delete my first, delete my second, and delete my third. Again, this is some delete operation which we have already seen as well. The second I run this, and let's say if I just go to the end, see, first, second, and third are getting deleted. And finally, we have a linked list kind of a structure, the one which I showed you, right? So I hope this is very much helpful in visualizing. Again, if you're able to visualize linked list, 90% of the work is done. Okay. So see, this is my head. This is my head. Let me just zoom in as well. This is my overall head, everyone. Now in this head, in this particular head, what all I am having, head is pointing to the first node. Okay. This first node is pointing to the second node. See, where the pointer is ending, it is pointing to the second node, and second node is finally pointing to the third node. Third node says that, hey, I am not pointing anywhere. Now, if we actually want, if we want in this particular thing, what we can do is, let me showcase that to you as well. We can do one more thing, right? So see, if I do print first dot next, now when I do first dot next, I am on second dot data. Okay. So what I'm doing is I'm saying, hey, first dot next. So I'm pointing here now, dot data. If I run this whole code, if I just run this full code, you will see how I will get 2. I'm getting 2 here. And I hope you're able to make sense of it, right? Because I went to first, ask it for it next. Using it next, I attempted to just get the data. The same thing is, of course, a lot expandable. First dot next dot next. And if I run this, I hope all of you are able to understand what the answer is going to be. It's going to be 3. Because I went to first, next, and then next of this particular as well. So I went to 3. And now I ask what your data is. So in a way, you will be able to see that just by using first, and I can of course make it head as well, because first and head are the same thing. And if I run this, it's same. So just using head, I am able to access each and every of my node, right? So I hope now the whole flow is a lot clear. So see, I'm able to access each and every of my node. 1, 2, 3. So I've just created this head, and I can access all my elements using this. Again, we can keep on adding any elements we want. We can delete elements as we want as well. Okay. Cool then everyone. I hope with this overall implementation, you have a good idea on how exactly can we go about making our own linked list. So we have created a node, and then we have just joined them to create our own linked list, right? Now, as we move forward, we are going to write many functions which will be helping us to take input, do different operations on our linked list. Okay. And then finally see that how we can just join all of them together into one class, one big linked list class. Okay. Cool then everyone. I hope this understanding was clear. Please make sure that you revise the concept of OOPS once again, because you will be using that a lot going forward. Okay. Thank you.